Hello my lovely juniors, welcome back. This is the week 2 and day 3. So in the part 3 we are learning about the types of AC motors and its applications in the industry. So the main things here is like this architecture I already explained you. So DC means direct current and AC means alternative current. So in the DC side we have brushless and brushed. So these brushes are the one which is using the induction into the motor. So there will be a rotor in the motor. So that like these brushes will induce the induction and which will create the magnetic field. So in the brushless we will not use the this concept. Okay. So in the brushed I will explain what is brushless. Okay. Under brushed we have series wound, shunt wound, compound and permanent magnetic. So this is some types of motors. And in the AC we have synchronous and induction. So induction is also called as asynchronous. Okay. So it is also called as asynchronous. So in the synchronous means just think that so we have one rotor and stator. Okay. So rotor means in the motor we have the rotating equipment. So if it is the motor like this, so there will be one inside one rotor. So it will be rotating. Okay. And stator is the body of this like this. So it will be stationary, it will not rotate, it will continuously, it will stay like this. Okay, this is the stator and this is the rotor. So in the asynchronous, if the rotor is in positive condition, so stator will be negative. If it is negative, positive. That's why these both will be not in sync. That is why it is called as asynchronous. But in the induction asynchronous, both rotor and stator, if it is positive, this is also positive. It is negative, then this is also negative. So the both will be in sync. Neutral, this one, N and S. So the both poles will be in the same thing. So that is called as the induction. So here we have the single phase and three phase. Here we will use the 230 volts and here 440 volts. Okay. Next, the AC motors flow chart. So we will have AC, as I told, induction is also called as asynchronous, and then the single and the three phase. And asynchronous I will explain now first. Okay. In the synchronous motor we have non-excited and DC excited. Non-excited motors, it means that these motors means reluctance, hysteresis and permanent magnetic motors don't need any DC current. Okay. How we will work? How it will work we will see. Okay. So this is how the synchronous motors look like. And if you see, this is the parts of the synchronous motor, as I told you, no, see, this is the rotor, stator. So it will be permanently, it will be in the stationary mode, it will not move. This is the rotor from here to here. See, this one will be rotating as we have, you can see windings here, copper windings. So because of this, one EMF will induce in the system, that is the electromagnetic force by which it will run. See, I told you, no, these are the brushes. Okay, these brushes will induct the magnetic force by which this slip rings will be running. And then we have a shaft here and also bearing. See, this is the bearing and we have one shaft, slip rings already I told you, this is the armature and this is the rotor stator and this is the foundation where this motor will be like static equipment, where it will be, motor is not static, but this one, the basement of the motor will be, it will be static. Okay. And then stator winding, and then we have also cooling fanning in order to protect the motor from the heat. Okay. And then definition of the synchronous motor, as I told you, it is an electric motor in which at steady state the rotation of the shaft is synchronized with the frequency of the supply of the current. So both will be in the sync mode. The rotation period is exactly equal to the integral number of the AC cycle. Okay. So like this. So if we have positive, also negative, like. And then definition of the non-excited motor. non-excited motors, the rotor is made of a steel. At synchronous speed, it rotates in step with the rotating magnetic field of the stator. So it has an almost constant magnetic field through it. It means that, as you see here, this is the stator and this is the rotor. Okay, so the stator will not require any additional DC current, because normally in the synchronous motor what we will do, we will give additional DC current, but in the non-excited motors what it will do, from the stator current only it will take this EMF only, it will induce here, from that one only it will be in sync with that and it will be rotated along with it. So that's why they mentioned at synchronous speed it rotates in step with the rotating magnetic field of the stator. So the external stator magnetic field magnetizes the rotor, inducing the magnetic poles and needed to turn it. So it is very simple. The rotor is made of a high retentivity steel in which the cobalt steel. These are manufactured in a permanent magnetic reluctance and like hysteresis design. So these are the non-excited three motors: magnetic, reluctance and hysteresis. Okay, the reluctance motor. Reluctance motor is a type of motor that includes the non-permanent magnetic poles on the ferromagnetic rotator. Normally we will the like magnetic rotator will be there, right? So in this one we will having the ferromagnetic, which is non permanent magnetic. This ferromagnetic in the sense, whenever we want we will turn that particular metal into the magnetic, otherwise not. The rotor does not have any windings, there will be no windings in this one. It generates a torque through the magnetic reluctance. That's why it is called as the reluctance motors. In this one we have two types: synchronous reluctance motor, and in this one we have switched motor or variable stepping motor. So, like how it will work? The synchronous reluctance motors have an equal number of stator and rotor poles. For example, if it is the stator is rotating like this, see, and also rotor also rotating in the same one, see, both will be same. The projections on the rotor are arranged to introduce the internal flux barriers, holds the direct magnetic field flux along so called the direct axis. So the number of poles must be even. It means the both should be same. So typical pole numbers are 4 to 6. The rotor operates at synchronic speed without the current conducting parts. Rotor losses are minimal compared to those of an induction motor. Okay. However, it doesn't normally have a lot of torque, because in the induction motor we have a very good torque. Here we don't see that much because there is no magnetic external magnetic field that we are giving through the DC current. So once the motor started at a synchronous speed, the motor can operate with the sinusoidal voltage. The speed control requires a variable frequency drive, as I told you, explained about VFD. So it requires an VFD to control. So then you can control the sinusoidal waves. If you want less speed, you can reduce the current. If you want more speed, you can increase the current. Okay. So what is the switched reluctance motor? So as I already told you, the SRM is a form of a stepper motor that uses the fewer poles. So the most rudimentary form of a SRM that has the lowest construction cost of an electric motor, because it is simple structure, and even industrial motors may have some cost reduction due to the lack of rotor windings and permanent magnetic. So as I am not completely electrical engineer or mechanical engineer, so I am explaining what all the with the minimal knowledge I have about these things. Okay. So if you want deep understandings, there are so many channels which are related to the electrical. If you go there, you can check with very animation and all. So these notes I have prepared you for the exam purpose, so you can write these answers whenever you are required. Okay. So this is for a switched motor. You can see the applications of the reluctance motors. You have analog electric meters and clocks, and like hard disk drive motors will use, electrical vehicles, and so many these are the applications of reluctance motor. And we have a hysteresis motor. This is also same as I told you, we no need to make an external DC current. So here again it is used with the cobalt steel. The material has a wide hysteresis loop, high corrosivity. So this is also same. And the hysteresis motor work, how the you can explain the how hysteresis motor will work. See, I can explain you before also, but like in the exams anyway you need to write all those things, but for the understanding, as I told you before, it doesn't need an excited DC current. So these are the advantages of motors. And then we have the permanent magnetic motors, this one, and then working of a permanent magnetic motor. So this is very simple. If you don't understand really what exactly how it is working, you can comment over that. I can explain each and every one of them very easily. So, and DC excited motors, as I told you before, there are some motors which we need the DC current. So like even though you can call it as brushless, okay. And induction motor flowchart. So we have single phase and three phase. So what is an induction motor? An induction motor or asynchronous motor is an electric motor in which the electrical current in the rotor needed to produce the torque. Electrical current is needed to produce the torque is obtained by the electromagnetic induction from the magnetic field of the stator winding. Electromagnetic field, EMF, okay. And then what is the single phase motor? As I told you, in the single phase we will use the 230 volt, and in the three phase motor we will use the 440 volt. Here we will be having the three phase RYB. So all we will be having the positive, 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 but here in the single phase one positive, one negative. So this is the three phase and this is the single phase, okay. So application of the AC motors. So there are so many, we will use in so many areas in the industry, okay. So in the next chapter we will discuss about the DC motors and its applications. So till then, see you, bye bye.